Hello, this is a short podcast on how to run the job for the calculations you're being asked to do this week in the Comp Chem lab. So I've logged into chemistry.ncssm.edu. I'm going to go up under new job and I'm going to say create a new job. There we go. In a second while this window opens. And I'm going to do fluorine. This is not one of the ones we demoed. So if I go under the build menu, you'll notice that fluorine is not there. I'm going to go over and I'm going to click, I can either click on other or I can click on the periodic table and I can pick fluorine. I'm going to click on it there. I'm going to click on the screen there. Fluorine is a green molecule. I'm going to go to the next window, and as it says in the lab, you want to run Gaussian, so I'm going to click on Gaussian. I'm going to go to the next window, and there's my fluorine. I want to do a molecular orbitals calculation. I want to use the theory Hartree-Fock and basis set. I want basic 321G. Notice that the charge is 0. It does tell me that the multiplicity is a doublet, and that's okay. We're going to leave that alone. Click on the next, go to the next window. The job should now be running. So you see that I'm now running. I can check my run by hitting the refresh button here and see how we're doing. This job should take about 10 seconds or so. Click on the refresh again, and there we go. I'm all done. Okay, I'm going to now click on the F for the molecule, and what I'm looking for is, if I scroll down, I'm looking for where is the highest occupied molecular orbital. Now this molecule, you don't see all of the electrons here. You should be seeing 9 electrons. I'm seeing 1, 2, 3, 4, 5, so I'm missing 4. What I need to do is go up under display range and notice that I should be seeing 18 orbitals. They're only showing me the first 8. So I'm going to change that 8 to an 18. I'm going to click on the refresh button, okay? And there you see the rest of my electrons. So I've got 5 up here and 4 down here, okay? What I'm now looking for is where is my highest occupied molecular orbital. It looks like it's probably in orbital number 13 with an energy of minus 0.63605. I'm going to copy that number, and I actually built a spreadsheet, okay, to help me analyze this data. So the HOMO was in orbital 13, the energy was minus 0.63605 Hartrees, and I'm now going to convert that to an ionization energy, and in a spreadsheet I'm going to say equals minus, I'm using Koopman's theorem now, okay, that number, and I'm going to multiply it times the conversion factor, which is 627.509 kilocalories per mole, and that'll get me my units in kilocalories per mole. At this point, so it says my ionization energy is 399 kilocalories per mole. The correct value, or the literature value, is 401 kilocalories per mole. So I did a percent error calculation. I'm going to do it, I'm using a spreadsheet here, and I'm going to go, and that tells me I got about a 1% error. Pretty good for using a relatively fast and inaccurate theory. So that's how you're going to do that. I hope this helps, and if you have any questions, send me an email and we'll help you out. Thanks. Bye.